Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into principal component analysis. And the principal component analysis is one of unsupervised learning algorithm in which the PCA is a statistical procedure that transforms a set of observations of possibly correlated variables into a set of values of linearly uncorrelated variable called principal component. So PCA is widely used dimensionality reduction technique that can be used to reduce the number of features in a dataset while preserving as much of the information as possible. So you can actually relate with the previous videos that we have been doing on PCA, and we have been saying that it is normally used to reduce the dimension of our data, dimensionality reduction. So in this case now, we are going to use a PCA in an iris dataset. So the first thing we need to do is to import our NumPy. Then we import our dataset, which is iris that we're going to deal with. Then now, from our scikit library decomposition, we need to import PCA. Then we need to extract the features that we need to use, which are the iris data. And after doing so, we need to create a PCA model with the two components. So our PCA here, number of components 2. Then we fit the PCA model to the data here. After fitting it, we transform the data to the PCA space. And now let us run our code. Right, after running our code, we can see that we get an array. So here in detail, we are explaining as follows that we first load the iris dataset, which is the data set of our flower measurement. Then it extracts the features from the dataset and create a PCA model with the two components that we have stated above on our line of code here with the two components. Then after doing so, the PCA model is fit to the data, and the data is transformed to the PCA space. So the dataset library in scikit-learn provides a number of datasets which including the iris dataset. So the PCA function in the scikit-learn .decomposition library takes the number of components as input and retains the PCA model. The fit method that we have seen above of the PCA model fits the model to the data. Then now the transform method of the PCA model, it transforms the data to the PCA space. So the PCA space here is a new space where the data points are uncorrelated. The first principal component is the direction of maximum variance in the data, and the second principal component is the direction of maximum variance in the data that is orthogonal to the first principal component. And I believe you understand the meaning of the word orthogonal here. So this is the data that we are having, that we have created in the code above. So this is the PCA space that we are having. This is the output that we are having. Now we are actually saying now the output of PCA.transformX is a matrix of transformed data points. The matrix has two rows which correspond to the two principal components and the number of columns in the original data set. So nothing has changed, but we just reduced the dimensionality of the data and maintain the number of rows on for the original data. Everything is well maintained. So now we need to use the data that we have solved and put in a PCA space. So we need to plot this data here, as you can see. So this is PCA1 and PCA2 and PCA for our iris data. So these are the labels that we are having. And remember, we have 3 types of flowers. This is the data that we are having, which is being clustered or grouped in different groups. And also, if you want to represent this data on a curve, okay, on a curve, it means that we just call our PCA again here, and we call our iris dataset, and we take our X data, we extract the feature here, which is X, which is our data, and we create the PCA model here, and we do not specify the number of components that we need. Then we fit the data here. And this data, remember, these are sepal and petal that we are having. And also we fit the PCA model here. After doing so, now we calculate the explained variance ratio here by PCA.explained_variance ratio underscore. By doing so, now we need to plot the explained ratio. So plot pyplot here, our matplotlib dot plot our explained variance ratio, then our principal component, our explained ratio, and the iris curve is our title. So iris data set. So PCA curve for iris data set that we are seeing. So this is just the curve that we are seeing. This is the principal component values that we are having, and this is the variance. So this is just a brief overview on how we can use a PCA on an unsupervised learning algorithm. Okay then, so I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye bye.